Let's start out today with a quick review of what we discussed yesterday in class. So we talked about a new type of equation called a quadratic equation. And what we learned is they all look the same. So every quadratic equation looks like y equals ax squared plus bx plus c. So notice that you have an x squared term, and a is the coefficient of that. And then you have a bx term, and b is the coefficient of that, and then a plain number out here on the end. And what we learned is that when we graph these quadratic equations, we get a U-shaped graph, and we get a U that either is right side up, like that, or we get a U that is upside down, like that. So quadratic equations all look the same, and they all have the same kinds of graphs. Now, we talked about some things that you need to be able to identify, so let's go back over those words again. So the first thing you need to be able to identify is the vertex, and you all will remember that that is either the highest or the lowest point. So if they ask you for the vertex, that's what they want. So on this U right here, my vertex would be the lowest point, and that would be a minimum. And on this parabola, or this U-shaped graph right here, my vertex would be the highest point, and would be located right there. So when they ask for the vertex, they want the highest or lowest point. Now, something else they want you to be able to identify are the x-intercepts. So they want you to know where the graph crosses the x-axis. And what we discussed is that there are 4 different ways that they can ask you for those x-intercepts. The first one is the obvious way. They can ask you what are the x-intercepts. And then the other 3 are not quite as obvious. They can ask you for the roots, for the zeros, and for the solutions. So all of those words mean what are the x-intercepts. So those are all different ways to say the same thing. And then the final thing they want you to be able to identify is the y-intercept. And that's a little easier because there's only one way they can ask you for y-intercept, and that is to use the phrase y-intercept. So this will always be obvious. This is highest or lowest. So what that means is all of the other words that they might use all mean the same thing, and they mean x-intercepts. Now, I do want to remind you that we did, in the problems that you did yesterday, see the word factor again. And factor is kind of special. It's kind of its own thing. So when you see factor, it should make you do some very specific things. The first thing it should make you do is GCD. The second thing it should make you do is type the whole problem in and get the x-intercepts. So notice, factor does make you get the x-intercepts. But then you don't stop there, because once you have those x-intercepts, that's when you factor flip them and get your final answer. So this is a quick rundown of everything that we discussed yesterday. And so now we're ready to add a little more onto this today. Okay, so today we are going to focus more of our attention on the solutions of quadratic equations. And I want you to remember, as we're doing this today, that solutions are x-intercepts. So the entire time that we're working on this today, I want you to keep in mind that solutions are x-intercepts. Now, I'm not really sure why, but on the SOL test, they are very concerned about you being able to figure out how many solutions a quadratic equation will have. So how many of these solutions or x-intercepts will any equation have? And what you need to know is that when we are answering the question, how many solutions, for quadratic equations, there are only three possibilities. Three possible answers to that question of how many solutions are there. One of the possibilities is that there will be no real solutions. And again here, I want to point out something. That word real, that's something that the SOL folks like to throw in to kind of make this sound fancier than it really is. So when they ask the question, how many solutions, one of the options is that there will be none. So no solutions, but they'll throw that word real in there. Don't let that throw you off, okay? A second possibility for the how many solutions question is that there will be one. So one real solution. And then the third and final possibility is that there will be two real solutions. So you're going to see them, and when we start our SOL review on Monday, you're going to see that they like to ask a lot of questions about this. How many solutions does this equation have? And there are only three possible answers that you can get. There are either no solutions, one solution, or two solutions. So those would be the three answers you could give. And notice here that because solutions means x-intercepts, if there are no real solutions, that means there are no x-intercepts. That means the graph shouldn't hit the x-axis at all. If there's one real solution, then there should be one x-intercept. We should see the graph hit the x-axis one time. And then finally, if there are two real solutions, there should be two x-intercepts. So always keep in mind that that word solution means x-intercept. So, I'm off the screen. Let me scoot that over so y'all can see here. All right, so now let's talk about this, okay? I'm going to show you two different ways that they want you to be able to answer this question of how many solutions does this quadratic equation have. Both of them we're going to use Desmos, okay? So both of these methods that I'm about to show you are going to be Desmos methods, okay? So let's see what we've got here, okay? So the first way, so let me do this, two methods. The first method is use Desmos to graph. So use Desmos to graph and count the x-intercepts. So this, by far, will be the easier of the two methods. So let me give you some examples. All right, so here's the first one we're going to do. Example 1. Y equals x squared plus 5x plus 4. So that's the equation. And the question they're going to ask you is how many solutions does that have, okay? So we are going to go to Desmos, and we're going to type this problem right here in. So I've got mine off the screen, but I'll scoot it over in a minute. It's y equals x squared plus 5x plus 4. So now let me scoot this over here where you can see it. So here's my quadratic equation, and then up here I can see my graph. And the solutions are the x-intercepts. So I can see that I'm hitting this x-axis 2 times. Once at -4 and once at -1. Now they don't care what those solutions are, so they don't care that it's -4 and -1. What they want you to do is tell them how many solutions are there. Well, this graph is hitting the x-axis 2 times, so you would tell them there are 2 real solutions. And that would be the end of that problem. That's all they want to know, is that there are 2 real solutions. And again, there are 2 because you are intersecting the x-axis 2 times. And the solutions are the x-intercepts. All right, so here's a second problem. So this will be example 2. All right, for this one, I have y equals x squared minus 3x minus 10. And again, the question is, how many solutions? So I'm going to bring this over here, and I'm going to do y equals x squared minus 3x minus 10. And I can see my graph right here. There's my u. If I want to know how many solutions there are, then I look for x-intercepts. So I've got one at -2, 0, and another at 5, 0. So notice again, this is a graph that is hitting the x-axis 2 times. So I would tell them that this one also has 2 real solutions. And that one's done. All right, example 3. Y equals x squared plus 10x plus 25. So y equals x squared plus 10x plus 25. All right, so I can see my u. Here's the x-axis. And what you notice this time is I'm only touching the x-axis at a single point, which is -5 or -5, 0, however you want to say that. So because I am only intersecting the x-axis one time, I would tell them that this is 1 real solution. So I hope you all see that this type of problem is very, very easy. Very, very easy. If they ask you how many solutions an equation has, you have the option of simply graphing it, putting it into Desmos, and then looking to see how many times it's hitting the x-axis. So continuing on here, y equals 2x squared minus 4x minus 3. So we've got y equals 2x squared minus 4x minus 3. There's my u. You can see the x-axis right here. So I'm hitting the x-axis at -0.58 and then some, and at 2.58 and then some. So, but again, we don't really care what those numbers are, we just care how many there are. So this would be another 2 real solutions situation. All right, y equals 4x squared minus 12x plus 9. So y equals 4x squared minus 12x plus 9. There's my u. Here's my x-axis. I'm intersecting one time at 1.50, so this would be one real solution. And then let's get one more in here. For example, 6. Let's do y equals x squared plus 3. So y equals x squared plus 3. So you've got your u right there. Here's my x-axis, and what you'll notice is this time this u is not touching that x-axis. It doesn't get anywhere near it. So this would be a no real solutions. And y'all will notice I almost wrote 0 right there. You could say that there are 0 real solutions for this one. So that would also be an acceptable way to answer that question. So for quadratic equations, solutions are x-intercepts. So if they ask you the question, how many solutions does this have? A quick and easy way to answer them is to graph it on Desmos and count the x-intercepts, because that will let you know if there are no real solutions, one real solution, or 2 real solutions. And again, those are the only options. Now, let's talk about method number 2. Now, method number 2 is a little more complicated, but we can still use Desmos to our advantage here. Method number 2, instead of graphing, is to use something called the discriminant. And that's something you will have never heard of before. This will be a brand new word for you, okay? Now, the discriminant has a formula. And the formula for the discriminant is b squared minus 4ac. So b squared minus 4ac.